Hello, and welcome to Sleepy Science Facts. I'm happy you are here. If you've had a long day, need to quiet your mind, or just enjoy falling asleep while learning something new, you're in the right place. Tonight, we'll softly uncover fascinating truths about science, guiding you toward rest and wonder. Tonight's journey takes us to Venus, the world that so often shines in our skies as the bright morning or evening star, yet hides behind thick clouds, a realm as strange as it is fascinating. Before we drift too far into the clouds of Venus, I would love to know where you are listening from. A quiet city apartment, a countryside home, or maybe somewhere in between. It's always wonderful to see how far these journeys travel across our own Earth. If this gentle voyage helps you relax, please do leave a like and consider subscribing for more calm explorations of science and space. To those who are already subscribed, thank you so much for being part of this community. It means the world. And if you'd like to be gently reminded when the next story is ready, tap the little bell so you won't miss a new upload. Now, I should offer a small warning. I hope the video isn't so interesting that it keeps you awake. But if it does, at least your dreams might be filled with volcanic mountains, swirling clouds, and the mysteries of a world both near and impossibly distant. So, what is it that makes Venus both our planet's twin and its most twisted reflection? Let's begin. Venus is often called Earth's sister, a planet born from the same swirling cloud of dust and gas, orbiting close to us in the same solar neighborhood. On paper, it should have been a familiar world, most the same size, made of the same basic ingredients, and with a similar position in the Sun's gentle habitable zone. And yet, what became of Venus could hardly be more different. When we look at Venus from Earth, it dazzles like a jewel. It is brighter than every star in the night sky, second only to the moon in brilliance. It has inspired myths of goddesses, love, and light. But behind that shining mask lies a planet that pushes the extremes of what a world can be. Where Earth has oceans, Venus has vast plains of basalt. Where Earth has blue skies, Venus has a heavy shroud of carbon dioxide and clouds of sulfuric acid. Where Earth has winds and rains that nourish life, Venus has storms that race around the planet at hurricane speeds and heat that never fades. For centuries, Venus has tempted us with questions. Could life ever have existed there? Did it once have oceans that boiled away under a runaway greenhouse effect? Is its surface still alive with volcanoes hidden beneath the veil of clouds? These questions have drawn spacecraft across the void, from the daring landers of the Soviet Venera program to the radar eyes of NASA's Magellan probe. Venus also holds a mirror to us. It shows what happens when a planet's climate tips too far, when balance is lost. Some scientists believe that billions of years ago, Venus may have been more Earth-like, with a gentler atmosphere and even liquid water. But while Earth nurtured life, Venus became a cautionary tale, furnace sealed in its own heat. And yet, it is not just the extremes that matter. There is a strange beauty to Venus, a kind of alien poetry in its endless clouds, in its slow backward spin, in its role as the brightest wanderer of our skies. It reminds us that even among worlds born as twins, destiny can diverge wildly. As we explore Venus, we will step carefully through its mysteries, its atmosphere, its surface, its storms, and its history, both in science and in myth. Along the way, we will uncover not just what makes Venus unique, but also what it can teach us about our own fragile home. So let us drift now gently into the thick yellow clouds of Earth's twisted twin and ask what secrets lie beneath the veil in the beginning. long before there were names, myths, or even an Earth to name them from. The solar system was a restless nursery. Clouds of gas and dust swirled around a young sun, clumping, colliding, and slowly shaping themselves into the familiar worlds we know today. Out of that turbulent disk of matter came to planets so similar in size, in mass, and in composition that it is hard not to think of them as siblings. One of those would become the Earth beneath your feet, and the other would become the strange, brilliant, and forbidding world of Venus. When you picture those earliest times, imagine not an orderly system of planets, but rather a cosmic demolition derby. Chunks of rock the size of cities were colliding daily, smashing together with enough energy to melt stone and spray molten debris across space. Some objects were swallowed up by the growing planets. Others were flung out into the cold reaches beyond the sun's light. For tens of millions of years, this was the background noise of creation violence on a scale we can barely comprehend, but one that was essential to forming stable worlds. Venus and Earth emerged from this chaos as near twins. Both are rocky planets made of the same basic element silicate forming their crusts, iron making up their cores. Both grew to almost the same size, Earth just slightly larger, but only by a narrow margin. Venus has about 90% of Earth's mass and almost the same diameter, so close that if you were holding models of the two planets in your hands, you would struggle to tell which one was the bigger dot. This is why astronomers call Venus Earth's twin. The resemblance is not perfect, of course, but the similarities are striking enough that they stand out from the rest of the solar family. The reason Venus and Earth ended up so similar lies in their birthplaces. They formed close together in the solar system's so-called habitable zone, the band around the sun where conditions are just right for liquid water. Slight differences in orbit meant that Venus circled a bit closer to the sun while Earth stayed slightly farther out. But in the early years, both planets were still in positions where they could have shared many of the same starting ingredients: water, carbon, nitrogen, and other building blocks of life. It is no surprise then that scientists often wonder what Venus might have looked like billions of years ago. Could it once have had oceans like Earth? Could it have been a truly habitable twin before its fate diverged? In those early days, both planets were subjected to heavy bombardment. Asteroids and comets delivered not only destruction, but also gifts. Many researchers believe that water arrived this way, carried inside icy rocks from the outer regions of the solar system. Picture massive comets slamming into the young Venus and Earth, vaporizing on impact, and leaving behind water molecules that eventually gathered into oceans, lakes, and seas. We cannot know for certain how much water Venus originally received, but evidence suggests it may have once had quite a bit enough that oceans could have covered much of its surface. If that is true, then the image of Venus as a dry, searing desert is only part of its long story. The story of siblings in space is not unique to Venus and Earth. Mars, smaller and more distant, is often described as a cousin, another rocky planet that seems familiar but different. Mercury, the smallest of the inner planets, is more like a wayward relative, stripped down to an iron core by violent impacts or the sun's searing heat. But among all these worlds, Venus stands out. It is not just similar to Earth in size. It also shares a comparable density and composition. If you could somehow lift Venus and Earth onto a cosmic scale, you would see that they are balanced almost evenly. Yet being twins does not mean being identical. Anyone with a sibling knows that from the very beginning. Venus's slight closeness to the Sun may have given it a different trajectory. Just a few million kilometers closer to the furnace of our star might not sound like much, but it was enough to set the stage for a world where conditions could easily tip from stable to extreme. The difference between a comfortable greenhouse and a runaway greenhouse is, after all, a delicate one to understand why Venus became Earth's twin in name but not in nature. It helps to linger on the image of that early solar system. Imagine molten surfaces glowing red as they cooled, vast seas of lava slowly hardening into crust. Both Earth and Venus would have gone through this fiery adolescence, their atmospheres thick with volcanic gases. As they stabilized, their similarities must have been astonishing, two planets of nearly equal stature with the potential to grow into fertile, dynamic worlds. From afar, they might have looked like twins dressed in the same colors, ready for lives that could have unfolded in parallel. Venus is also called Earth's twin because of the way it shines in our sky. It reflects sunlight with dazzling brilliance, often mistaken by casual observers for a star. That brightness is part of what made ancient cultures so attentive to it, weaving it into stories and legends. It was easy to think of Venus as a counterpart to the Moon, a guiding light that mirrored something of ourselves back to us. The science of its twinship, its size, its mass, its density would only come much later, when telescopes and mathematics revealed how much it truly resembled our home planet. But the intuition was there from the start. Venus feels like something familiar, and familiarity is what we humans grasp at when looking into the night. If you hold on to that image of Venus as a sibling, it helps to frame everything that follows. Twins can share origins, but their paths can diverge wildly. In one, you see oceans, forests, and life. In the other, you find volcanic plains, crushing pressure, and heat so intense it defies imagination. The story of Venus and Earth is a story of how similar beginnings can lead to radically different endings, and how fragile the balance of habitability really is. So when astronomers call Venus Earth's twin, they are not exaggerating. They are pointing to a relationship written in the very numbers that define the planets, their diameters, their densities, their positions in the solar system. Venus is the sister planet that could have been a second Earth, a reminder that chance and circumstance matter deeply in the making of worlds. Looking at Venus is a little like looking in a mirror and seeing not yourself but an alternate version, shaped by just a few small differences at birth. It is that reflection, familiar yet hauntingly altered, that has made Venus a source of both wonder and caution since the day we first lifted our eyes to the sky. If you're enjoying this gentle voyage to Venus, Earth's mysterious twin, you'll love the rest of our Sleepy Planet series, a soothing exploration of every world in our solar system. New episodes release each week, joining a playlist that lets you drift from planet to planet, uncovering the beauty, mystery, and calm that fill the spaces between the stars. Look up on a clear evening just after the sun has dipped below the horizon, and you may notice a light so brilliant that it seems to outshine every star. That light is not a star at all, but Venus, the brightest planet in our sky. Its radiance is so intense that it can even cast faint shadows on a moonless night. Under the right conditions, it can even be spotted during the day if you know exactly where to look. This dazzling brightness has always set Venus apart, making it a familiar presence for anyone who spends time gazing at the heavens. The reason Venus appears so bright is not a trick of distance alone. Mercury, after all, is closer to the Sun, and Mars often comes nearer to Earth, but Venus wears a cloak of thick clouds that reflect sunlight with remarkable efficiency. Those clouds act like a cosmic mirror, scattering sunlight back toward us and giving Venus a visual presence far greater than its actual size would suggest. To the naked eye, it simply looks like a jewel pinned against the fading blue or the velvet black of night. It's no wonder that ancient people gave it names and wove it into myths long before telescopes revealed its true nature. For observers on Earth, Venus follows a curious pattern. It never strays far from the sun in the sky. Because of this, you will never find Venus high overhead at midnight. Instead, it appears either in the western sky just after sunset or in the eastern sky just before sunrise. This has given Venus two enduring identities: the evening star and the morning star. When it lingers in twilight after the sun has set, it seems to escort the day into night. When it rises before the dawn, it seems to herald the coming of daylight. In both roles, Venus has been seen as a messenger, a guide, and sometimes even a trickster, appearing and vanishing with predictable but mysterious rhythm. That rhythm comes from the dance of orbits. Venus circles the sun in about 225 Earth days, but from our perspective, it alternates between trailing behind the sun and racing ahead of it. When Venus is west of the sun, we see it in the morning sky before sunrise. When it swings east of the sun, it appears in the evening sky after sunset. Its brilliance makes it one of the first stars to appear in the twilight and one of the last to vanish when daylight takes over. Entire civilizations once watched these appearances closely, using them as markers of time, omens of change, or signs from the heavens. In ancient Mesopotamia, Venus was associated with Inanna or Ishtar, goddesses of love, fertility, and war. The duality of Venus, as both morning star and evening star, mirrored the duality of those deities, bringers of life and also of conflict. Babylonian astronomers tracked Venus with meticulous care, noting its cycles and predicting its appearances with impressive accuracy. Their records show that Venus was not just a point of light, but a celestial personality woven into the fabric of their culture. The Greeks and Romans carried this tradition forward, though with their own interpretations to them. Venus was Aphrodite, goddess of love and beauty, whose brightness and constancy reflected divine presence. The Romans gave the planet the name we still use today, linking it forever to ideals of charm, attraction, and allure. And yet, even among these associations with beauty, the ancient world knew there was something deceptive about the planet's shifting appearances. Some early thinkers even believed the morning star and the evening star were two entirely different bodies, only later realizing they were one and the same. For the Maya, Venus was far more than a beautiful ornament in the sky. It played a role in calendars, rituals, and even warfare. The Maya tracked Venus with extraordinary precision, recording its cycles in the Dresden Codex. They believed its appearances could influence human affairs, and some battles were planned to coincide with its rising. For them, Venus was a powerful cosmic influence, not merely a pretty light. The accuracy of their Venus tables is astonishing proof of how carefully they observed its movements. In cultures as far apart as Polynesia and North America, Venus was also significant. Navigators used it as a guide across oceans, while storytellers wove it into myths about ancestors and spirits. The universality of Venus is striking. No matter where humans settled, they could not ignore this dazzling wanderer. Its steady brilliance gave reassurance. Its shifting roles sparked curiosity. and its predictability offered a sense of order in a chaotic world. Even today, Venus has a way of catching us off guard. Someone walking at dusk might glance up and mistake it for a passing aircraft, its steady glow seeming too bright for a planet. Amateur astronomers often choose Venus as one of their first targets, only to find that through a telescope, it does not look like a star at all, but a small disk with changing phases. Much like the moon, these phases occur because Venus, like the moon, reflects sunlight toward us from different angles as it moves around the sun. When it is on the far side of the sun, it appears nearly full. When it swings closer to Earth, it shows a slender crescent, a delicate reminder that appearances in the sky are a matter of perspective. There is something soothing in knowing that this cycle continues without fail. Venus will always return as morning star and evening star, keeping time on a cosmic scale that is both ancient and yet ever new. Our ancestors marked their lives by its rise and fall, and in a quiet way, we still do. Farmers once watched for Venus in the dawn sky as a seasonal marker. Poets invoked it as a symbol of longing or renewal. Even in modern times, Venus appears in songs, literature, and metaphors of love and mystery. But beyond myth and metaphor, the sight of Venus has a simple human effect. It draws the eye upward. It asks us to pause for a moment in the bustle of daily life and notice the vastness of the sky. Its brilliance is a reminder that the universe is always present, even if most of the time we're too distracted to notice. There is comfort in knowing that long before telescopes, before science, before history as we record it, people were already watching Venus and feeling that same quiet sense of awe. When you next find yourself outdoors at twilight, try looking to the west after sunset or to the east before dawn. The brightest light you see will almost certainly be Venus. And in that simple act, looking at a planet shining across the void, you will be sharing in a tradition older than writing, older than cities, older than nearly everything we think of as civilization. It is the same light that guided sailors, inspired myths, and stirred questions that science is still answering today. Venus in the night sky is more than a planet. It is a bridge between past and present, between myth and science, between wonder and understanding. If you were to drift downward through the shining clouds of Venus, the view would quickly change from dazzling beauty to suffocating hostility. At first, from orbit, the planet looks wrapped in a smooth blanket of white and pale yellow, featureless except for subtle swirls. But descend into those clouds, and you would find yourself surrounded by thick layers of carbon dioxide, laced with droplets of sulfuric acid. The sunlight above becomes filtered and broken, creating an eerie orange glow by the time you reach the surface. The pressure would be 90 times greater than what you feel on Earth, and the heat would climb past 460 C, hot enough to melt lead. It is a world that greets visitors with a slow, crushing embrace. The heart of the mystery lies in the atmosphere itself. Nearly all of it is carbon dioxide, over 96% in fact. The rest is a mix of nitrogen and trace gases. But carbon dioxide dominates in a way unlike anywhere else in the solar system. On Earth, carbon dioxide is a tiny fraction of our air, measured in mere parts per million. Yet on Venus, it has become the very essence of the atmosphere, a thick soup that traps heat with ruthless efficiency. This difference alone explains much of why Venus is so hostile while Earth remains habitable. The clouds add another layer to the story. Suspended in the Venusian skies are countless droplets of sulfuric acid, formed from volcanic gases and chemical reactions high in the atmosphere. These clouds reflect sunlight brilliantly, which is why Venus shines so brightly in our sky. But beneath that mirror-like layer, the atmosphere acts like a thermal blanket, letting light in but refusing to let heat escape. It is a classic greenhouse effect, but on a planetary scale and taken to its extreme conclusion. To understand the greenhouse effect, imagine sitting in a car on a sunny day. Sunlight pours in through the windows, warming the interior, but the heat does not escape easily, and soon the car becomes uncomfortably hot. Now imagine the same process but with an entire planet trapped inside the car. That is Venus. Energy from the sun enters through the cloud tops, is absorbed by the ground, and then radiates back upward as infrared heat. But instead of escaping into space, that heat is absorbed and re-radiated by the carbon dioxide-rich atmosphere, bouncing around until the entire planet reaches a sweltering equilibrium. What makes Venus's situation so extreme is the feedback loop. At some point in its history, Venus may have had water, but as the planet warmed, oceans evaporated into the atmosphere. Water vapor is itself a powerful greenhouse gas, which trapped more heat, causing even more water to evaporate. The cycle fed on itself until every trace of surface water was lost. Once the oceans were gone, the planet had no way to draw carbon dioxide out of the air. On Earth, much of our carbon dioxide is absorbed into oceans and locked away in rocks. Venus lost that stabilizing mechanism, and the carbon dioxide piled higher and higher into the sky. The result is a surface hotter than Mercury's, even though Venus is almost twice as far from the Sun. Mercury has no atmosphere to speak of, so heat comes and goes freely. Venus, on the other hand, holds on to every scrap of warmth day and night across the entire globe. That is why the temperature on Venus does not vary much between poles and equator or between night and day. Everywhere you go, the furnace is on full blast all the time. It is worth pausing to ask why Earth avoided this fate. After all, the two planets started with so much in common. Part of the answer is distance. Earth orbits just far enough from the Sun that its surface temperature allowed liquid water to remain stable for billions of years. Those oceans acted as a climate regulator, absorbing carbon dioxide from the air, dissolving it, and eventually locking it into carbonate rocks on the seafloor. Life played its role too. Plants and microbes helped cycle carbon, creating oxygen and maintaining a delicate balance. Plate tectonics also makes a difference. On Earth, moving plates recycle carbon between the surface and the interior. Volcanoes release it, while weathering and ocean processes draw it down. Over geological timescales, this system has prevented carbon dioxide from spiraling out of control. Venus, with its immobile crust, may never have had that safety valve. Once its climate tipped toward heat, there was no mechanism to bring it back. Another factor is the Sun itself. Billions of years ago, the Sun was dimmer, giving Venus more breathing room. But as the Sun slowly brightened, Venus crossed a threshold beyond which stability was impossible. Earth remains just outside that danger zone for now. Our planet sits in the habitable zone, but only just. And scientists sometimes describe Earth as living on the inner edge of safety. Venus shows us what happens when that edge is crossed. The chemistry of Venus's atmosphere also creates strange weather. Clouds of sulfuric acid swirl at high altitudes, carried by winds that race around the planet in just 4 Earth days. These upper clouds are surprisingly cool compared to the furnace below, but they're far from friendly. If you could float in them, you would be bathed in corrosive acid mist. Occasionally, these clouds rain sulfuric acid droplets downward, but before they can reach the ground, the heat evaporates them, creating a cycle of acid rain that never quite lands. It is a bizarre twister planet where it rains, but the rain never touches the soil. Lightning may crackle within these clouds as well, though it is hard to detect. Some spacecraft have picked up signals that suggest electrical storms flicker across the sky, though others remain uncertain. If true, it means Venus has another way of discharging its immense atmospheric energy, echoing thunderstorms on Earth, but in a far harsher environment. Despite its dangers, Venus's atmosphere fascinates scientists because it holds clues to both planetary history and our own future. The runaway greenhouse effect is a stark warning about the power of atmospheric change. On Earth, small increases in greenhouse gases cause measurable warming. On Venus, the effect was allowed to run unchecked, producing a world that is utterly unrecognizable compared to its twin dot. The lesson is sobering. The balance of climate is fragile, and once lost, it can be nearly impossible to restore. And yet, Venus's atmosphere is not only a warning, but also an opportunity. It is a natural laboratory for studying how atmospheres behave under extreme conditions. By sending probes into its clouds and studying its chemistry from afar, scientists can refine their models of climate and apply those lessons to Earth. In this way, Venus, though uninhabitable, becomes a silent partner in understanding the forces that shape habitable worlds. So when we call the atmosphere of Venus mysterious, it is not just because it hides the surface beneath a permanent veil of clouds. It is because it represents both a past we can only imagine and a future we must strive to avoid. It is at once a cloak of beauty and a curtain of fire. A reminder that even twin planets can tell very different stories. Venus, with its endless carbon dioxide and its sulfuric haze, is a vision of what can happen when a world tips too far. And in that vision lies not only mystery, but also a reflection of our own fragile balance back here on Earth. Imagine for a moment that you could somehow descend through the clouds of Venus, protected from the searing heat and acid rain. As you approach the surface, one of the first things you would notice is not just the temperature, but the weight of the air itself pressing in on you from every direction. On Earth, we're used to an atmosphere that is comfortable, light enough to let us breathe, and heavy enough to keep oceans and weather in place. On Venus, that same concept has been taken to an extreme. The pressure at the surface is about 90 times greater than what you feel at sea level here on Earth. To put that into perspective, it would be the same as standing a full kilometer beneath the ocean on Earth, with the weight of all that water pressing down. This staggering pressure is one of the most alien features of Venus. If you or I were to stand there unprotected, it would not be a dramatic explosion or violent tearing apart that ended us. Instead, it would be a slow, crushing inevitability. Your lungs would not be able to expand. Your body would be squeezed from all sides, and every bit of air inside you would be forced out. Human beings were never designed to withstand such immense atmospheric weight, and even our most advanced machines struggle to survive in it. The Soviet Venera probes that landed on Venus in the 1970s were built like deep-sea submersibles. They had to be engineered with thick, armor-like shells, and even then, the longest any of them managed to survive on the surface was just over 2 hours before the heat and pressure overwhelmed their systems. It is difficult to imagine what such pressure feels like because our lives are so attuned to the relatively gentle weight of Earth's atmosphere. At sea level here, the air presses down with about 1 kilogram per square centimeter. You do not feel it because your body pushes back with equal force. But on Venus, that pressure multiplies to 90 kilograms per square centimeter. Every square centimeter of your body would be carrying the equivalent of a person standing on it. Multiply that across your entire frame, and the sensation becomes impossible to bear. It is a reminder that on Venus, even something as simple as the air is not a gift but a danger. One of the easiest ways to relate to Venusian pressure is through the comparison to Earth's oceans. Divers know that for every 10 meters of depth, the pressure increases by about 1 atmosphere. To experience the conditions of Venus on Earth, you would need to sink to around 900 meters underwater. Few humans have ever descended that far, and those who do rely on submersibles or specialized equipment that can withstand the crushing depths. The idea that on Venus this same force is present not beneath an ocean but as part of the very air itself is almost surreal. Instead of open skies and breathable air, the planet's surface is more like a deep abyss where the sky itself is heavy enough to crush. It is worth pausing to ask why Earth avoided this fate. After all, the two planets started with so much in common. Part of the answer is distance. Earth orbits just far enough from the Sun that its surface temperature allowed liquid water to remain stable for billions of years. Those oceans acted as a climate regulator, absorbing carbon dioxide from the air, dissolving it, and eventually locking it into carbonate rocks on the seafloor. Life played its role too. Plants and microbes helped cycle carbon, creating oxygen and maintaining a delicate balance. Plate tectonics also makes a difference. On Earth, moving plates recycle carbon between the surface and the interior. Volcanoes release it, while weathering and ocean processes draw it down. Over geological timescales, this system has prevented carbon dioxide from spiraling out of control. Venus, with its immobile crust, may never have had that safety valve. Once its climate tipped toward heat, there was no mechanism to bring it back. Another factor is the Sun itself. Billions of years ago, the Sun was dimmer, giving Venus more breathing room. But as the Sun slowly brightened, Venus crossed a threshold beyond which stability was impossible. Earth remains just outside that danger zone for now. Our planet sits in the habitable zone, but only just, and scientists sometimes describe Earth as living on the inner edge of safety. Venus shows us what happens when that edge is crossed. The chemistry of Venus's atmosphere also creates strange weather. Clouds of sulfuric acid swirl at high altitudes, carried by winds that race around the planet in just 4 Earth days. These upper clouds are surprisingly cool compared to the furnace below, but they're far from friendly. If you could float in them, you would be bathed in corrosive acid mist. Occasionally, these clouds rain sulfuric acid droplets downward, but before they can reach the ground, the heat evaporates them. This comparison brings to mind the resilience of life on Earth, in our own oceans. There are creatures that thrive under immense pressure, living happily at depths that would flatten us. On Venus, however, there is no such refuge. The heat and chemistry of the air, combined with its pressure, create conditions that are inhospitable to life as we know it. And yet, considering the extremes life has survived on Earth, scientists continue to wonder whether microbial life might exist higher in the Venusian clouds, far above the crushing surface, where the pressure is less severe and the temperatures are more forgiving. From a geological perspective, the high pressure has fascinating consequences. Rocks and minerals behave differently when subjected to such forces. The melting points of substances can shift, chemical reactions can occur more quickly, and the way sound travels changes dramatically. If you could clap your hands on Venus, the sound would not carry as it does here. It would be muffled and strange, distorted by the density of the air. The landscape would feel eerily quiet, not because there is no medium for sound, but because the pressure would swallow it in a heavy, stifling silence. The experience of standing on Venus would also be visually bizarre. The dense atmosphere would scatter and absorb light differently than we are used to. So the sky would appear a murky orange-brown rather than blue. Objects in the distance would be blurred by the thickness of the air, as though you were looking through fog or water. Even the sun itself would appear dim and distorted, its light filtered down until it was just a faint glow struggling to pierce the haze. You would not see a bright star above, but rather a pale disk robbed of brilliance. Engineers who dream of exploring Venus often describe it as more challenging than Mars. Despite Mars being farther away, the red planet is cold, dry, and dusty, but its pressure is thin. Its climate extreme yet survivable with the right technology. Venus, by contrast, is close enough to tempt exploration but hostile in every possible way. Heat-resistant alloys, pressure casings, and advanced cooling systems are all needed just to last a few hours. Every attempt to reach the surface is like sending a submarine not into water but into fire. The pressure also affects the way the atmosphere circulates. With such density, winds carry more force, and even modest breezes have the momentum of gale-force winds on Earth. At higher altitudes, winds whip around the planet at hurricane speeds. Though near the ground, the air moves more sluggishly. Still, every movement of that thick atmosphere adds to the sense of weight, pressing down constantly, a reminder that Venus is not just another planet, but an environment entirely its own. What is striking about Venus is that such pressure is not inevitable. Earth, only slightly farther from the Sun, developed an atmosphere that is far lighter, breathable, and balanced. The difference lies in history and feedback loops. Earth's oceans absorbed carbon dioxide and stabilized our climate. Venus lost its water, and without that buffer, the gas piled up, thickening the air until it became the oppressive blanket it is today. What began as a sibling planet became, through a series of divergences, an alien world where the very sky acts like an ocean pressing down on everything beneath it. When you think of Venus in these terms, it becomes less like a neighbor planet and more like a parallel reality. It shows us what happens when a world tips too far in one direction. Pressure, in this case, is not just a physical force, it is a symbol of imbalance, of a planet trapped beneath the weight of its own atmosphere. And in that sense, Venus tells us a quiet story of how fine the line can be between habitability and hostility. So if you were ever to stand on Venus, it would not feel like standing on solid ground beneath open skies. It would feel like standing beneath an ocean of air, pressed from all sides, surrounded by heat and silence. The sun a faint glow above a crushing veil. It is an image both humbling and haunting, a reminder that in the grand family of planets, even near twins can grow into places so utterly different that one becomes a cradle for life and the other a world under unrelenting pressure. If there is one thing we tend to take for granted, it is that planets spin in a certain way. Earth rotates from west to east, giving us a sunrise in the east and a sunset in the west, a rhythm so familiar that it feels universal. But Venus refuses to follow this rule. Instead, it turns backward, a retrograde rotation that makes its day unlike any other in the solar system. On Venus, the sun rises in the west and sets in the east, a topsy-turvy reversal that leaves astronomers both fascinated and perplexed. The strangeness does not end there. Not only does Venus spin backward, but it spins so slowly that a single rotation takes 243 Earth days. In other words, one Venusian day is longer than its entire year, which lasts just 225 Earth days. Imagine living on a world where a year passes before you can complete a single spin. Time itself would feel bent out of shape, and the familiar rhythm of day and night would be unrecognizable. Why Venus spins in reverse is still something of a mystery. The leading theories point to the early chaos of the solar system, when giant impacts were commonplace. A massive collision could have knocked Venus off balance, slowing and even reversing its rotation. Another idea suggests that tidal interactions between Venus and the Sun gradually altered its spin, dragging it into this strange state over billions of years. Perhaps it was a combination of both a colossal impact to start the process and then the gentle, but relentless pull of the Sun to finish it. Whatever the cause, the result is one of the oddest rotations in the solar system. The consequences for sunlight are dramatic because of the slow rotation and the thick, heat-trapping atmosphere. A single day on Venus is not like the clear cycle we know on Earth. If you stood on the surface, it would take months for the sun to rise, crawl across the sky, and then set. Each moment would be stretched into a slow-motion sequence, as though time itself had grown heavy. Twilight would last for weeks, the glow lingering in the dense air long after the sun dipped below the horizon. Then, when night finally arrived, it would stretch on and almost endless before the next sunrise came crawling from the opposite direction. This strange rhythm creates a disconnect between Venus's solar day and its actual spin. A solar day, the time from one noon to the next, lasts about 117 Earth days on Venus. This happens because the planet's retrograde spin interacts with its orbit around the Sun, effectively shortening the daylight cycle even though the rotation itself is longer. The math is peculiar, but the effect is simple. Time on Venus is distorted in a way that defies our usual experience. Days and years lose their familiar meaning, and sunlight behaves in ways that feel alien. Imagine trying to live under such conditions. On Earth, our biology is tied to a 24-hour cycle. Plants open and close their leaves. Animals hunt or sleep. And humans build entire societies around the predictable rhythm of day and night. On Venus, with a day that stretches longer than a year, life as we know it would struggle to adapt. Plants would bake for months under relentless sunlight, then freeze in the long, dark night. Animals would find their instincts utterly mismatched to the planet's tempo. The only life that could possibly survive would have to adapt to conditions so extreme that it is difficult for us even to imagine. This backward spin also means that the winds and weather patterns on Venus are shaped in unusual ways. While the surface air moves slowly, high above the clouds, the atmosphere whips around the planet in just 4 Earth days, a phenomenon known as superrotation from the surface. You might not notice the winds, but above your head, the skies would be racing eastward, completing a full circuit while the ground beneath you crawls slowly in the opposite direction. It is as if the atmosphere itself cannot be bothered to wait for the planet's sluggish spin. The retrograde rotation also adds a layer of complexity to how we view Venus from Earth, observing its phases through a telescope. Astronomers noticed that the planet appeared to move across the sky in ways that defied simple expectations. Galileo, when he first saw Venus showing crescent and gibbous phases, realized it must orbit the Sun, not Earth. Centuries later, scientists pieced together that its odd movement and rotation were unlike anything else nearby. Venus became not just a bright ornament in the night sky, but a puzzle in celestial mechanics. There is something almost poetic about a planet that insists on doing things backwards. It serves as a reminder that the universe is not obliged to follow patterns that make sense to us. For every Earth with its comforting 24-hour day, there can be a Venus with a year that slips by faster than a single rotation. And yet, despite this oddity, Venus continues to move in a steady, predictable orbit, keeping time with the rest of the solar system. Its difference is not chaos, but simply another form of order, one we must stretch our minds to comprehend. If you were to stand on Venus and watch the sun rise in the west, you might feel the disorienting sensation of living in a mirror world. The familiar cycle of east to west would be reversed, and every instinct about time and direction would be challenged. It is a thought experiment that makes one appreciate just how much of our sense of order comes from the simple turning of our own world. Beneath the sun, Venus shows us that even in a family of planets, born from the same disk of dust and gas, the details can vary so wildly that one sibling spins comfortably forward while another lingers backward and slow. In that strangeness lies a deeper lesson. Time, sunlight, day and night things we take for granted are not universal constants, but fragile arrangements. Dependent on the quirks of planetary history, Venus is the twin who chose a different rhythm, a reminder that even in the orderly dance of the cosmos, there is room for worlds that march to their own peculiar beat. On Venus, heat is not a passing phase of the day or a seasonal shift. It is a permanent state of being. The surface simmers at an average of about 460 C, a temperature hot enough to melt lead or zinc. There are no cool evenings, no chilly mornings, and certainly no winter reprieve. The planet exists in an eternal furnace, where the concept of weather is not about variations in temperature, but about how that overwhelming heat interacts with the thick atmosphere and restless clouds. If you could stand there, surrounded by jagged volcanic plains and mountains hidden beneath the sulphurous sky, the heat would press against you without mercy. It is startling to realize that Venus is actually farther from the Sun than Mercury, and yet it is hotter. Mercury, being closest to the Sun, might seem like the natural candidate for the hottest world. But Mercury has almost no atmosphere, so while its daytime side bakes in direct sunlight, its nights plunge into extreme cold. The planet cannot hold on to its heat. Venus, on the other hand, has a dense, choking atmosphere of carbon dioxide that traps heat with extraordinary efficiency. Once energy from the sun gets in, it has little chance of escaping. The result is not just a warm climate, but a thermal prison. The greenhouse effect is familiar on Earth, where it keeps the planet's surface from freezing solid. Without it, our world would be an icy ball, far less hospitable. But like all good things, there is a balance. On Venus, that balance spiraled out of control. Carbon dioxide makes up more than 96% of the atmosphere, and with such an abundance, the greenhouse effect has gone into overdrive. Heat comes in, but it cannot leave. Even at night, even at the poles, even on mountain peaks, the temperature stays almost the same, unbearably high, unchanging, and indifferent to the rhythms that govern Earth. One of the strangest consequences of this runaway greenhouse effect is how uniform the heat is. On Earth, You can feel the difference between the warmth of the equator and the chill of the poles, or between day and night. Venus erases those distinctions. Because its atmosphere is so dense, heat is distributed evenly across the globe. Winds at high altitudes whip around the planet in just a few Earth days, carrying energy and blending it into a nearly uniform climate. No matter where you go on Venus, the thermometer points to the same impossible number. This unrelenting heat also shapes the geology of the planet. Metals that are solid on Earth would soften or even melt under Venusian conditions. Lead, for instance, would pool into liquid, and zinc would behave the same. Even substances we think of as rugged and dependable would struggle in such a world. The surface rocks themselves glow faintly in infrared, radiating energy that struggles to pierce the carbon dioxide blanket above. It is as though the entire planet is locked inside a slow cooker, sealed shut and turned to its highest setting. The balance that governs planetary temperatures is usually a dance between incoming solar energy and outgoing thermal radiation. On Earth, sunlight warms the ground, which then radiates heat back into space. Venus disrupts this balance. The thick carbon dioxide atmosphere is excellent at absorbing infrared radiation, bouncing it back toward the ground again and again. Each attempt at cooling is met with resistance, and over time, the system tips further out of equilibrium. This is thermal balance gone wild, a feedback loop that no natural mechanism has been able to halt. Scientists believe Venus may not always have been this way. In its earliest history, it may have had milder conditions, perhaps even oceans. But as the sun slowly brightened over billions of years, water began to evaporate. Water vapor itself is a greenhouse gas, and as it built up in the atmosphere, it trapped more heat. This heat evaporated more water, which trapped more heat still. Eventually, the oceans boiled away entirely, and Venus was left with a barren surface and an atmosphere dominated by carbon dioxide. Without oceans to absorb carbon, there was nothing to regulate the climate. What might have been a temperate twin of Earth became a permanent inferno. The thought that Venus could once have been more Earth-like is both tantalizing and unsettling. It suggests that planetary habitability is fragile, that a few shifts in distance, composition, or timing can lead to radically different outcomes. On Earth, water cycles through oceans, clouds, and rocks, helping to moderate our climate. Life itself plays a role in keeping balance, with plants and microbes pulling carbon from the air. Venus, lacking these stabilizing systems, was vulnerable to tipping into its current state. Once the process began, there was no turning back. The permanence of the heat is another sobering fact. Because Venus's atmosphere is so dense and its greenhouse effect so strong, its surface temperature does not fluctuate much over time, whether in day or night, summer or winter. The environment is locked in place. This constancy is alien to us, accustomed as we are to seasons, cycles, and weather shifts. On Venus, the only rhythm is the endless hum of heat, the ground always glowing, the air always heavy with energy that cannot escape. The human imagination has often turned Venus into a stage for science fiction. Early writers once dreamed it was a jungle world hidden beneath the clouds, steamy and lush. Others imagined vast oceans or strange swamps. When the truth was revealed, it proved more extreme than anyone guessed. Instead of rainforests, there is a desert of volcanic rock. Instead of tropical rain, there are sulfuric acid mists. Instead of steamy warmth, there is a deadly, lead-melting inferno. Reality, in this case, was more dramatic than fiction, and yet, even in its hostility, Venus has a strange beauty. To know that a world can glow like a star in our night sky while hiding such extremes is humbling. It makes Earth's balance of temperature and climate feel all the more precious. The lesson of Venus is not just about science, but about perspective. It shows us that the conditions we take for granted, cool evenings, flowing rivers, snow on mountain peaks, not universal. They are delicate, the result of finely tuned balances that can be disrupted. So when we speak of the heat on Venus, it is not merely a number on a thermometer. It is a story of imbalance, of a world where thermal equilibrium broke down and never recovered. It is a reminder that in the cosmic lottery of conditions, even twin planets can land on very different fates. Venus, shining so serenely in our skies, is in truth a furnace that never cools, a place where heat is not a passing season but the very definition of existence. The most striking feature of Venus, even from far away, is its cloak of clouds. Unlike Earth's skies, which break open to reveal blue during the day and stars at night, Venus is forever wrapped in a thick, luminous shroud. These clouds are not made of water vapor as ours are, but of sulfuric acid, one of the harshest substances known to us. Imagine a world where every puff of cloud is laced with acid, where the rain that forms is not refreshing but corrosive, and where even the possibility of seeing a clear horizon is denied. This is the realm of Venus, a world of fire and mist. The sulfuric acid clouds begin high in the atmosphere, forming dense layers that stretch for many kilometers. They are born from chemical reactions between volcanic gases, carbon dioxide, and the relentless ultraviolet light of the sun. Sulfur dioxide rises from the surface through volcanic outgassing, mixes with water vapor, and reacts under solar radiation to create droplets of sulfuric acid. These droplets cluster together, drifting and swirling in vast formations that give Venus its dazzling brightness when seen from Earth. The irony is that the very thing that makes Venus sparkle like a gem in our night sky is the same thing that makes its skies so unforgiving. In these clouds, rain does form, but it is nothing like the nourishing rain of Earth. Sulfuric acid droplets grow heavy and begin to fall, pulled downward toward the surface. For a brief moment, you might imagine the landscape being pelted with acidic rainfall, carving rivers and dissolving rocks. But that image never becomes reality. As the raindrops descend into the lower atmosphere, they meet temperatures so extreme that they evaporate long before reaching the ground. The rain is born in the clouds, begins its descent, and then vanishes into vapor, returning to the cycle above. It is a planet of ghost rain, where droplets endlessly fall and fade, never touching the surface they seem destined for. Though we have learned much about Venus from radar and orbiters, many questions remain unanswered. How often do its volcanoes erupt? How thick is its crust? Is there still movement beneath the surface, subtle but steady, reshaping the land in ways we cannot yet see? These mysteries continue to draw scientists back to the planet again and again in the coming decades. New missions are planned to revisit Venus with instruments far more advanced than those of the past. NASA's Veritas mission and the European Space Agency's Envision spacecraft are both designed to map the surface with unprecedented precision. They will search for signs of active volcanism, measure how the surface flexes, and study the chemistry of the atmosphere to understand how the planet evolved. Another mission, Da Vinci Plus, aims to send a probe directly through the atmosphere, taking samples and images during its descent. For a brief time, as it falls through the clouds, it will see what no human eye ever has: a direct view of the surface, glimpsed through the yellow haze. These missions are not just about exploring a hostile world. They are about understanding planetary processes more broadly. By comparing Venus with Earth, scientists hope to learn how climate, geology, and habitability are connected. Venus offers a natural experimental world where the same ingredients produced such a different outcome. The questions it raises are not just scientific, but philosophical. Could Earth, under slightly altered conditions, have suffered the same fate? What keeps our world balanced where Venus tipped into chaos? These are the questions that keep Venus at the heart of planetary science. Despite its heat and pressure, Venus has become one of the most intriguing places to study. Every discovery there reflects light back on us, helping us understand not only what went wrong on our sister planet, but what continues to go right on our own. And there is another reason to return to Venus' beauty. Beyond the data and the danger, there is something profoundly moving about this world. Its golden clouds, its hidden surface, its soft light seen from afar all, combine to create an image of mystery and endurance. To study Venus is to study contrast, beauty and brutality, similarity and strangeness, hope and warning. Some dream of exploring its upper atmosphere, where the pressure and temperature are surprisingly close to those of Earth, around 50 kilometers above the surface. The air thins enough to become more forgiving. There, in the temperate layers of the Venusian clouds, temperatures hover around room level, and pressure matches what we feel at sea level on Earth. These conditions have led to imaginative proposals for floating habitats, balloon cities, suspended above the deadly surface. In theory, humans or robots could one day drift through those skies, shielded from acid but free of crushing weight, studying the planet below. It sounds like science fiction, but it is rooted in real physics. Engineers have calculated that lighter-than-air craft filled with breathable air would actually float in Venus's dense atmosphere. Such ideas capture the imagination, blending curiosity with courage. Whether or not such missions ever happen, the concept reflects how human exploration always seeks balance between danger and discovery. Venus, more than almost any other planet, embodies that tension. It is at once inviting and forbidding, a mirror that shines brightly even as it warns. As we prepare to return, it feels as though we are not just visiting another world, but confronting an alternate version of our own. Venus reminds us that planets, like people, can share origins yet diverge in destiny. Its story is a lesson written in light and fire, a tale of balance lost and extremes embraced. But even in its harshness, there is wonder. From afar, it glows softly in the evening sky, the same way it has for countless generations. No matter how much we learn about its deadly surface or its suffocating air, that glow never loses its power. To look at Venus is to look at a paradox, a planet of beauty and destruction, of silence and violence, of brilliance and despair. It is Earth's twin, and yet its opposite. It is the warning star and the wonder star, the brightest point in the sky and the darkest mirror of what could have been. So tonight, if you happen to see Venus shining above the horizon, pause for a moment. Remember the world beneath those clouds, the molten plains, the mountains of stone, the endless acid skies. Remember that it once might have been like Earth, and that in its brilliance we see both the fragility of our own home and the resilience of the cosmos. And as you breathe under the soft air of our own blue planet, Think of that golden twin, glowing in the distance, forever beautiful, forever untouchable, lesson in light, and a lullaby from another world. Even after centuries of observation, Venus continues to surprise us. Each time our instruments become more refined, the planet reveals a new secret or deepens an old mystery. One of those mysteries lies in its rotation and how it interacts with the atmosphere. The thick blanket of air that cloaks Venus doesn't merely sit still. It moves with astonishing speed, circling the planet every 4 Earth days. This superrotation means that the atmosphere moves 60 times faster than the surface below. The cause of this phenomenon is still not fully understood. Scientists suspect that sunlight heating the upper layers, combined with planetary waves and tidal forces, drives the winds into motion. Over time, the energy gets trapped in the atmosphere, pushing it into a perpetual whirl. If you were floating in a balloon above Venus, you could drift around the entire planet in less than a week, while the ground far below hardly turns at all. This circulation also affects how heat is distributed. Because the atmosphere moves so quickly, it spreads warmth evenly, explaining why the planet's temperature remains constant across its surface. Even the poles, which receive less sunlight, are nearly as hot as the equator. In the dim light beneath the clouds, it would feel as though the entire planet existed in one endless afternoon, with no cool mornings or long nights to offer relief within these clouds. Lightning may flash, illuminating the mist for brief moments. Some probes have detected bursts of electromagnetic energy consistent with lightning strikes, though others have not confirmed them. If they exist, these storms would be unlike anything on Earth. On Venus, the lightning would flash not through water clouds, but through a haze of acid and sulfur. The light would scatter and glow, diffused by the thick air, turning the sky into a brief shimmer of amber before darkness closed in again. Another mystery involves the planet's magnetic environment, or rather, its lack of one. Unlike Earth, Venus has no strong magnetic field to shield it from the solar wind. Yet its dense atmosphere still manages to interact with the charged particles streaming from the sun, creating a kind of induced magnetosphere. This interaction strips away some of the planet's upper atmosphere over time, blowing ions into space. Despite this loss, the atmosphere remains thick, suggesting a steady replenishment, perhaps from volcanic gases rising from below. It is strange to think that a world so inhospitable could still be so active. The forces shaping Venus are not gentle, but they are persistent. Every layer, from its molten core to its acid clouds, participates in a slow dance of balance and imbalance, loss and renewal. And in studying these processes, scientists gain insight not just into Venus, but into how atmospheres behave. Everywhere from Mars to exoplanets orbiting distant suns, Venus has also become an important reference point in the search for life beyond Earth. When astronomers find exoplanets similar in size and mass to our world, they often ask, are they more like Earth or more like Venus? The answer depends largely on the atmosphere. A planet that begins with too much carbon dioxide, or one that drifts too close to its star, can end up following the same path as Venus, trapped in a runaway greenhouse, its oceans lost, its surface scorched. In 2020, a team of researchers announced a curious discovery: traces of phosphine gas detected in Venus's clouds. On Earth, phosphine is produced by certain microbes and industrial processes, leading some to speculate that life might exist high above the surface, in the more temperate layers of the atmosphere. The idea captured the public imagination, though it remains controversial. Subsequent studies questioned the data, suggesting that the signal might have been an artifact or the result of other chemical reactions. Still, the episode reminded scientists how little we truly know about Venus. If there were microbes floating in its clouds, they would need to survive in a highly acidic environment, something difficult but not impossible, as certain extremophiles on Earth can thrive in similar conditions. Future missions may look for organic molecules or other signs of chemical disequilibrium that could hint at biological activity. Even if no life is found, the effort to search teaches us more about the boundaries of habitability. Venus forces us to confront what it means for a planet to be alive, not in the biological sense, but geologically and chemically. Its constant circulation, volcanism, and atmospheric reactions make it dynamic in ways that defy the idea of a dead world. It breathes gases, reshapes itself, and interacts with the sun in a continual exchange of energy. It may not host life, but it behaves like a living system all the same. The fascination with Venus extends beyond science into culture and imagination. Throughout history, it has been a symbol of duality, beauty and danger, love and destruction. In ancient mythology, it was a goddess. In modern times, it is a warning. The more we learn about it, the more it mirrors our own concerns about climate and balance. Its story is both cosmic and personal, reflecting our fears and hopes about the fate of worlds. To astronomers, Venus is also a test of technology and endurance. Every mission sent there faces one of the most challenging environments in the solar system. Electronics must survive heat that would melt metal, and instruments must resist acid that corrodes almost everything. The Soviet Venera landers of the 1970s and 1980s were engineering marvels. They descended through the atmosphere on parachutes, enduring crushing pressure and heat, sending back brief images and data before they succumbed. The photographs they captured remain haunting. The landscape appears orange and dim, with flat rocks scattered across dusty plains. The horizon curves subtly under the dense air, and everything seems bathed in twilight. Those few pictures, transmitted through thick clouds before the landers failed, are our only direct glimpses of the surface of Venus. They show a world that is both alien and strangely familiar, a rocky desert under an eternal sky. The Venera images were short-lived transmissions, but their impact was immense. For the first time, humanity had seen the face of its sister planet, not as a distant point of light, but as a tangible place with ground, stones, and horizon. In those faint orange photos, there was a sense of presence, as if the planet were no longer just a symbol or a mystery, but a real world with a history of its own. Each mission that followed built upon that foundation, seeking to uncover what lay hidden beneath the clouds. Later orbiters refined our maps, revealing a landscape shaped by forces as intense as any in the solar system. They showed volcanoes taller than Everest, valleys as long as continents, and plains that once flowed with molten rock. The radar reflections traced patterns that hinted at movement and change crustal deformations that might still be happening today. Every detail deepened the mystery rather than solving it. Venus became the great paradox: static yet dynamic, quiet yet powerful, familiar yet alien. Scientists began to see it not merely as a hostile world, but as a living archive of planetary evolution. Studying it became a way to glimpse what might happen to Earth if balance were ever lost. The idea of a runaway greenhouse ceased to be just theory. It had already happened there, and in that realization lay both awe and unease. Venus is our closest planetary neighbor, but it is also a warning written across the sky in golden light. Its very beauty hides the lesson it carries. To the naked eye, Venus is pure elegance, glowing brighter than any star. It rises gracefully in the evening or heralds the dawn, earning its ancient names as both the evening star and the morning star. Poets and dreamers have long found inspiration in its steady light. Yet behind that brilliance lies a reality of unbearable heat, unbreathable air, and crushing pressure. It reminds us that beauty can conceal danger, and that what seems serene from afar may be raging within. In this duality, Venus reflects something of ourselves. Humanity too shines with brilliance and creativity, even as it wrestles with the consequences of imbalance. In studying Venus, we are, in a way, studying the edge of habitability, the fine line between a thriving world and one consumed by its own atmosphere. Venus may have crossed that line long ago, but Earth still stands on its near side. Watching. The future of Venus exploration is entering a new era. For years, Mars has drawn most of the attention, with rovers, orbiters, and plans for human missions. But now the gaze is returning to the second planet. Engineers are developing new materials and technologies that could withstand the furnace of its surface longer than any probe before. Some propose using error-breaking spacecraft that dip in and out of the atmosphere to collect data over time, while others dream of long-lived landers, powered by advanced cooling systems. There are even ideas for Ariel, platforms floating laboratories that drift in the temperate layers of the clouds, where conditions are almost Earth-like. From there, instruments could study the chemistry, observe lightning, and look down upon the surface with powerful radar eyes. These concepts mark a return not only to exploration but to curiosity itself, driven by the same wonder that once inspired ancient stargazers. For the scientists who dedicate their careers to Venus, it is more than just another target. It is a world of unanswered questions, of extremes that test every theory of planetary behavior. How does a planet lose its water? How does it sustain such thick air? Could it ever cool again? These are not abstract questions, they reach into our understanding of all worlds, including our own. Venus also plays a quiet but profound role in Earth's own climate studies. The models that help predict global warming are tested against what we know of Venus's runaway effect. By studying its clouds and radiation balance, climatologists refine their understanding of feedback mechanisms that could one day affect Earth. In that sense, Venus is not just a cautionary tale, but a vital laboratory, a place where the limits of atmospheric physics are on display. Even as we learn from its past, Venus continues to hold its mysteries close. The planet rotates so slowly that its core and mantle behave in ways still not fully understood. Does it have tectonic motion deep beneath the crust? Does its interior still churn with magma seas? And if it does, how do those forces shape the surface we see today? The answers will not come easily, but every new mission brings us closer. One day, perhaps, we will send a probe that endures for months instead of hours, transmitting high-resolution images and samples from the surface. We might map temperature changes in real time, or watch the slow motion of clouds from above. When that happens, Venus will move from mystery to understanding, but even then, its beauty will not fade. Some worlds are defined as much by what they hide as by what they reveal. To gaze at Venus is to feel that mixture of knowledge and wonder, of science and poetry. It is a reminder that even in a universe governed by physics, there is room for awe. The same sunlight that burns its plains also makes it shine in our sky. The same chemistry that smothers its air also paints it with gold. Venus may be a furnace, but it is a furnace that glows with elegance, a paradox that keeps us looking upward, dreaming, learning, and wondering.